This video is over section 9.5, Exponential Equations and Applications. This has been talked about before, but just really quick, the equivalence property of an exponential expression states that if b, x, and y are real numbers with b greater than 0 and b not equal to 1, then b to the x equals b to the y implies that x equals y. So here, if we have the same base b, then we can set their exponents equal to each other. All right, so we're going to try to get that on these first two. The first two says solve the following for the given variable. We have 4 to the 2x minus 3 is equal to 64. Now on the left we have a base 4, and on the right we have a 64, but I know that 4 cubed is equal to 64. So I can rewrite this as, I'm going to write it a little bit bigger so I have space. 4 to the 2x minus 3 is equal to 4 cubed. And I know that because 4 times 4 times 4 is 64. And off to the side, I'm just going to make a note that we want the bases the same, if possible. And I'll put that in parentheses, if possible. I'm not sure if it's this video or a different video, but yeah, it is this video. There is a time where they will not be the same. Okay, so now by the equivalence property, since we both have a base 4 and 4, we can set the exponents equal to each other. So now our problem becomes 2x minus 3 is equal to 3. And we are allowed to do that by the equivalence property. Okay, which says that because the bases are the same, we can set the exponents equal to each other. All right, then I just solve for x. Oops, I put a 6 here, I didn't mean to. 3, sorry. Hopefully you can see that this 3 goes here, my bad. Okay, and I'm going to be left with 2x equals 6. Oops. And divide by 2, and I have x is equal to 3. Great. All right, on the right I have 27 to the 2w plus 5 equals 1/3 to the 2 minus 5w. Here, there's not an easy way to make 27 into a 1/3 base or 1/3 into a 27 base. However, I can make these both into a 3 base. So 27 is the same thing as 3 cubed, 3 times 3 times 3. And I'm going to leave that 2w plus 5 on the outside. Okay, and then same thing on the right side, 1/3 is the same thing as 3 to the negative 1 power. And then I'm going to leave the 2 minus 5w on the outside. Okay, now we have, so I guess let me make a note out to the side. Here we want same base, if possible. So I'm going to put want same base if possible. And now that we have the same base, we can take the exponents equal to each other. So here we have 3 times 2w plus 5 is equal to negative 2 minus 5w. So you have to remember from Algebra 1, but if I have power to a power, that means multiply. All right, so now I'm going to solve for w. On the left, I have 6w plus 15 equals, on the right, I have negative 2 plus 5w. I'm going to move my w's to the left, so I'm going to subtract 5w, and then I'm going to move my 15 to the right, so I'm going to subtract 15. When I do that, I end up with w is equal to negative 17. And w is by itself, so we are finished. See if I can get that. Awesome. All right, this next section says solve the following exponential equations using logarithms. So here we may or may not have the same base, so we're going to have to use logarithms. So really quick, if we are going from exponential to logarithmic form, let me move this over. The exponential form would be y equals b to the x. And equivalently, the log form would be x equals log base b to the y, or of y. I'm going to put a box around this, but this will be useful for us for this section when we can't get the same base. All right, so on this first one, I have 5 to the x equals 8. I need to switch the form. I'm given this exponential form. I need to go to the log form. So I'm going to show all my work. You could probably just skip right to the answer, but here I'm given this form here. So if I line it up perfectly with this, I have my base is 5. My exponent is just x, and then my y is 8. So I'm lining up that perfectly. Oops. Erase that and erase that. Okay, so now that I have my b, x, and y, I can write it according to the log form. And when I do that, I will have x is equal to log base 5 of 8. I probably showed way more steps than I needed to, but I went from this form to this form. Okay, and that is probably going to be fine in the assignment, but if not, you can type this in your calculator and you're going to get 1.292. In the calculator, I guess I'll use green here. In the calculator, there is a way to get the log base. Let me see if I can quickly find it. Yeah, so if you hit math and you scroll until you find log base, then you'll be able to type that in your calculator. So I'll highlight that in green. But if you're using a calculator, the TI-84 specifically, then you should be able to pull this up perfectly in your calculator. There is a workaround if you don't have that, but I think most of the calculators now have that in it. All right, for the next problem, I have 400 plus 100, or sorry, 400 plus 10 to the 4x minus 1 is equal to 63,000. I need to get this exponent, the part with exponent by itself first. So the first thing I need to do is subtract 400. And when I do that, I have 10 to the 4x minus 1 is equal to 62,600. Okay, here, again, I'm going to be looking at this orange box. I have the exponential form. I need to switch to the log form. And when I do that, I'm not going to show as much work as I did before. When I do that, I'm going to have log base 10 of 62,600 is equal to 4x minus 1. Now, let's make a note off to the side. Remember, log base 10 is the common log. So you don't need to write the 10. Okay, I'm writing shorthand, but just log is acceptable. I guess let me write that instead. So just writing log is acceptable. So I'm going to go back and change mine, but I just wanted you to see it's log base 10, so I'm going to take off that 10. All right, we're solving for x, so I need to add 1 to both sides. You could go ahead and get a decimal from here. I'm just going to keep it separate till the end. So I have log of 62,600 plus 1 on the outside of the log is equal to 4x. And then I need to divide by 4. And I divide everything by 4. And my x is going to be equal to log of 62,600. And outside of that, I have plus 1, and all of that is over 4. And if I wanted to actually get the decimal for that, you could use the fraction button in your calculator, and then I would follow these green steps, math, and then find log base. Or I guess this one doesn't have a base, so it's just log 10. So you can just use the log button, which is on the left side of the calculator by the 7. So if I do that, I get that x is approximately 0.9491. Great. Okay. This next one I have 100 is equal to 700 e to the negative 0.2k. I need to get this exponential part by itself, so I'm going to get rid of that 700 by dividing by 700 on both sides. 100 divided by 700 is 1/7, and I'm left with e to the negative 0.2k. Here I have exponential form and I need the logarithmic form. And so I'm going to have log base e of 1/7 is equal to negative 0.2k. And off to the side, I need to remember log base e is the natural log. So it can be written shorthand ln instead. Okay, so I'm going to go over here. I'm going to erase log e, and I'm going to write ln instead. Just looks a lot better. All right, I'm going to divide by negative 0.2, divide by negative 0.2. So I have that k is equal to, and right here, it's not a huge deal, but if I divide by negative 0.2, that gives me a 5. Sorry, a negative 5. ln of 1/7. And I do want to approximate that. Let me double check this. Negative 5 ln of 1/7, and I get 9.7296. So I'm writing a lot of decimals, but you can kind of write what you want here. Great. All right, last one in this section, I have base 3 and a base 2. There's a lot of different ways to tackle these. I don't know that you'll have one this hard in your homework, but I did want to include one in the video just in case. And so I'm going to make my pen a little bit smaller. You're going to have to write pretty tiny in the boxes, but off to the side, when bases don't match, I'm going to take out don't. Yeah, I'll leave it down. Don't match or can't match easily. We're going to apply the log to both sides. Okay, so when they don't match or can't match easily, we're going to apply the log to both sides. Let me smooth that over. Okay, like I said, we're going to have to write really tiny for this, but if I write the log of both sides, I'm going to have log of 3 to the 5x minus 6 is equal to log of 2 to the 4x plus 1. And notice I did the same thing on both sides. I keep equality because I did the log of both sides. Now I'm going to apply the power rule, which says that these exponents can move to the front. Okay, so I'll write that in orange in a second, but that will leave me with 5x minus 6 log of 3 is equal to 4x plus 1 log of 2. Okay, and just so you know, here from here to here, I used the power rule. Okay, so after I applied the power rule, I'm going to distribute this 5x minus 6 with the log 3. So I'll use orange so you can see that, but I'm going to multiply this by log 3 and this by log 3. And then on the right, same thing with log 2. Multiply by log 2, multiply by log 2. So what that gives me is I'm going to have 5x log 3 minus 6 log 3 is equal to 4x log 2 plus 1 log 2, or just log 2. And from here to here, I distributed. Okay. After that, I want to move my x's to the left side and move my non-x's to the right side. So I'm going to take this one over there and this one over here. So when I do that, I'm going to subtract 4x log 2 and minus 4x log of 2. And I'm also going to add 6 log of 3 and add 6 log of 3. Okay, so it's really messy. We'll clean it up, but these two cancel out and these two cancel out. Notice here I can't really combine these because they have different logs, so I'm just going to write it out as 5x log 3 minus 4x log of 2 is equal to, and then the same thing, I can't combine the right side either. 6 log of 3, I put log of 3 first, it doesn't matter, plus log of 2. Okay? All right, so now I'm going to factor out an x here. These both have an x in it, so I'm going to divide out an x. And left would be 5 log of 3 minus 4 log of 2 equals, I'm not going to change anything about the right side, 6 log 3 plus log of 2. So I'll just make a note. I guess from here to here, we moved x's left. And from here to here, we factored out an x. Okay, and then once I factored out that x, I'm going to divide both sides by 5 log of 3 minus 4 log of 2. So I'm dividing by 5 log of 3 minus 4 log of 2. So that cancels these out like we wanted to, and that gets x by itself. I wrote too big, but here I'll write down here so I don't smush it all. X is equal to 6 log of 3 plus log of 2 all over what we divided by, 5 log of 3 minus 4 log of 2. And I don't think they're going to ask you to combine them. We could combine them all back because all these logs have the same base and we're adding and subtracting. I'll come back at the end of the video and maybe do that, but for now, let's estimate this in our calculator. When we type that in carefully, we get 2.6778. Great. All right, this next problem says, oops, I forgot to erase the answer here. Determine how long it will take $8,000 compounded monthly at 6% to double, round to 1 decimal place. So we need to pull back that equation that we talked about a while ago, which is let me get a bigger pen again. A is equal to P times 1 plus R over N to the NT. And we need to talk about what each of those variables mean, but this is the equation for compound interest. So A is the final amount. P is the principal amount. And what that means is basically initial. We use P for principal, but same thing. Okay, R is a rate as a decimal. N is how many times we're compounding. Okay, and there's an N here as well. So both those are the same N. And then T is the time in years. Okay, so going back and reading the problem, we have $8,000, so that would be our principal, would be 8,000. 6% to compounded monthly, so our ends are going to be 12. The rate is 6%, so 0.06 is our decimal. And then double, so the final amount is to double the 8,000, so our final amount is going to be 16,000, and we don't know the time. That's what we're looking for. Okay, so when we plug that in, we're going to have 16,000 is equal to 8,000 times 1 plus 0.06 over 12 to the 12t, and we're going to be solving for t. Okay, the first thing I'm going to do is I'm going to divide by 8,000. So I'm going to have 2 is equal to, and then I'm going to go ahead and add these two together. And when I do that, I get 1.005, and then I still have to the 12t. Okay, I'm going to use logs to change this from exponential to log form. So this is going to be log base 1.005 of 2 is equal to 12t. I could type this in the calculator now, but I'm going to divide by 12 first. And I get t is equal to log base 1.005 of 2 over 12. And then that doesn't really make sense in the context of the problem. They want us to get a decimal with, or sorry, yeah, one decimal place when rounding. So let me go ahead and do that in my calculator very carefully, just so I don't mess up. And I get 11 point, it says 1.6, and then t is in years. Okay. I don't know why I did that arrow.